In this video, we'll look at scientific notation. Scientific notation is a convenient way to express very large or very small numbers. So for example, a number like 1,925,000, or an even larger number. So that would be an example of a very large number, or something like 0.00000000375. That would be an example of a very small number that it would be good to use scientific notation for. A positive number is written in scientific notation when it is expressed in the form a times 10 to the n, where a is between 1 and 10, and n is an integer. Now, an integer is a whole number, but it could be a positive or a negative whole number. When n is negative, the standard form of the number is a small number, or less than 1. So for example, this 0.0000000000375. Then we would write it as a times 10 to a negative n, a negative number, and that would indicate that we move the decimal n places to the left. So for example, let's look at this one. Let's say I had 3.75 times 10, and let me figure out how many spots I would have to move that. I would have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So times 10 to the negative 10. To write this in standard form, I would take that decimal and move it to the left however many places I have in the exponent here. And that would actually be equivalent to this number. I would fill in with zeros for any of the blank spaces after I move the decimal. When n is positive, the standard form of the number is a large number, meaning greater than 10, and that would be a times 10 to a positive integer, and that would indicate that you move the decimal place n places to the right. So for example, if I had 1.925 times 10 to the 6th power, 6 is a positive, I would take that decimal and I would move it 1, 2, 3, 4, 5, 6 places to the right and fill in with zeros, and that would be equivalent to the 1,925,000. Let's look at a couple examples here. We want to convert 7.2 times 10 to the 5th to standard form. So we don't want that times 10 to a power. So what I'll do is I'll write my 7.2, and then the 5th power indicates that I have to move the decimal 5 spots to the right. A positive exponent correlates to a large number. So positive exponent on the 10 means that the result, or the standard form, will be a large number. So I'm actually going to take that decimal, I'm going to move it 5 spots to the right. So 5 spots. And I'll fill in with zeros. And so my final answer then will be 720,000. So 720,000. That will be that number in standard form. Now I want to convert 3.54 times 10 to the negative 4 to standard form. And in this case, I have a negative exponent. That indicates a number less than 1. So a negative exponent means a very small number. Or in other words, less than 1. And so what I'll do is I'll take my 3.54 and I'm going to leave some room on the left here. And I'm going to move the decimal 4 spots because it's a negative 4. So I'll move it 4 spots, 1, 2, 3, 4 to the left and fill in with zeros. And so my final answer is going to be 0.000354. That would be the standard form of 3.54 times 10 to the negative 4th. All right, so that's going from scientific notation to standard notation. Now we want to be able to go the other way too. Express using scientific notation, and we're given 610 million. So what I will do is I will take the decimal. To get into scientific notation, I can only have one non-zero digit before the decimal. So I'm going to count how many times I have to move that decimal to get only one digit, one non-zero digit before the decimal. So I have to move it 1, 2, 3, 4, 5, 6, 7, 8. So I move the decimal 8 places. And so the scientific notation equivalent of this number is going to be 6.1 times 10 to the positive 8. Now, knowing whether to use a positive or negative exponent, what you want to consider is, did you start with a really large number or did you start with a small number less than 1? Here we started with a very large number, and so it's going to be a positive exponent. So I have that 8 to indicate how many places I had to move the decimal, and I'm going to use a positive for the exponent because I started with a large number. All right, now let's look at this last one. I have a small number, and I'm trying to convert to scientific notation. Okay, so express using scientific notation 0.00397. And what I want to do is get only one non-zero digit before the decimal place. So I'm going to move that decimal 1, 2, 3 spots. So I move the decimal 3 places. And again, this is to get exactly one non-zero digit in front of the decimal. So the scientific notation would be 3.97 times 10, I moved the decimal 3 places, so I'm going to have a 3 up there, but it will be a -3 because I started with a small number that was less than 1. So the negative exponent corresponds to a small number less than 1. Okay, so those are the basics of converting between standard form and scientific notation. Now, in the calculator, if you're using a TI-84, scientific notation shows up with a capital E. So if you saw something like this, 4.284900039, capital E, -6, that is indicating times 10 to the -6 power. So that number would be 4.284900039 times 10 to the -6. So that capital E takes the place of the times 10 to the -6.